Okay, so picking up in this next video, we're actually kind of leaving off just where we are picking up right where we left off. All right, the lines M and L are intersecting, form an 81-degree angle. What's the angle of rotation that would map the green triangle onto the blue triangle? All right, so we're doing a reflection over this line and a reflection over this line. So we go from green to red, from red to blue. But since we're doing a double reflection over intersecting lines, it's going to be the same as a rotation. We can actually just rotate the triangle. It's going to be a rotation of 2 times 81, which equals 162 degrees. All right, so that's that theorem right there. And the last transformation problem right here is we have a double reflection over parallel lines. All right, so let's just label this picture first and then we'll talk about things. So A to A prime is 12 inches. So we're doing a double reflection. Write that down, double reflection over intersecting lines. Or excuse me, that should say parallel. No, I spelled lines weird. Well, I spelled it right. It just looks weird. Over parallel lines. All right. So A to A prime is 12. These lines themselves are 14. What is the distance between A prime to A double prime? That's what we're trying to figure out. Well, remember when you have a double reflection over parallel lines, it's same as a translation doubled the distance between the parallel lines. So, what does that mean? If these lines themselves are 14 apart, A to A double prime is 28 apart. All right, so this whole distance is 28. If this part's 12, I know this isn't to scale. What's this remaining part? Well, it's just 28 minus 12. This would be 16. So from A to A double prime is 16. All right, that's it right there. All right, that wraps up transformation. And remember, transformations were all congruent transformations. When you slide a shape, translations, the triangles are still the same, or the shapes are still the same. Same as a reflection. When you look in a mirror, you still see yourself. You don't see somebody else. And a rotation, the shapes are still congruent after you spin something. And that leads us up into triangle congruence proof. So let's just dive in. All right, congruency statement. This is a congruency statement. All right, and remember, they're very well written. Now I had some copy and pasting errors, so this looks a little goofy, but nonetheless, PQR is congruent to triangle XYZ. Well, remember, like the P corresponds to X, Q corresponds to Y, and R corresponds to Z. All right, so angle X and angle P are both first, so I jumped to B first for some reason. That means angle X is going to be congruent to angle P. Now let's talk about this side length. We should go in order probably. PR, XZ. Then we got ZX, RP. So the order of these letters are very important when dealing with a congruency statement. And then Q corresponds, angle Q is going to be congruent to angle Y. Those are both the middle letter. So congruency statement, order matters. It's important, very purposeful. It's a really good skill to be able to interpret the congruency statement. All right, and then given that the two triangles are congruent, find all missing angle measures. All right, so first, let's find angle 1. Let's just go in order. Well, angle 1, actually these triangles aren't congruent, but nonetheless, given that the two triangles, let's just say find all missing angle measures. All right, silly me for saying triangles are congruent. Anyways, we can find angle 1. How? Triangles add to 180 degrees. So I can say 90 plus 58 plus the measure of angle 1 equals 180. All right, so I'm going to get 148 plus the measure of angle 1 equals 180. So I'm going to get the measure of angle 1 equals 32 degrees. Well, guess what, people? Angle 1 and angle 2 are vertical angles. All right, so measure of angle 2 is also 32 degrees. And then results in the same method as finding angle 3, we're going to say 32 plus 108 plus the measure of angle 3 equals 180. A bunch of math happens, a miracle occurs. It's going to be 40 degrees. All right, so triangle sum theorem. Remember, triangles add up to 180 degrees. We can use logic to find angle measures such as vertical angles and other methods. Okay, that's it for this video. Stay tuned for more.